Alright, let's take a look at yet another free response question. Hope these are helpful for you to pause the video, try the problem, and then try to make sense of what I'm saying about it. You've got a table up here, and it's got the days in this first column, and it's got the water temperature in degrees Celsius, and it's differentiable, so they tell you that. And the table above shows the temperature recorded every 3 days over a 15-day period. So we have to approximate on part A to use the data to find the derivative at 12 days. So certainly we know that the temperature is 22 degrees there, but we're interested in the derivative of that. So we're looking at it with respect to time, so it's going to be WT over T. So the units there would be degrees Celsius over time, and that's just the slope. So what we're going to do is we're going to just use the point 3 days prior at 9 days, and then we're going to use the point at 15 days, and we're going to use that to approximate what the slope might be at right there in the middle at 12. So it says show your computations that lead to your answer, and I believe that this is calculator active. I think that's what this little guy over here means. So we'll certainly take advantage of that when we need to. So the proper way to get your full points on this is to say that W prime T, actually we don't need the T there, do we? We need to go ahead and just put our number, 12 days is equal to W at 15 minus W at 9 all over 15 minus 9. That's our days. So we have that's equal to 6 over 21 minus 24, and that would take us down to 3 over 6, negative 3 over 6, or a negative 1/2. So at this point we can just say that the derivative at 12 is equal to negative 1/2 of a degree per day. So it looks like the temperature is dropping a half a degree every day in that little time period. So that's probably the best estimation. Let's take a look at part B. It says approximate the average temperature in degrees Celsius of the water over the interval of 0 to 15 by using a trapezoid approximation, and our delta T is every 3 days, which is what our table is set up for. So let's go ahead and kind of cram for space here, so let's do this right here. So we're going to use our trapezoid, but before we do, we want to talk about the average temperature. So the average temperature here, if we just talk about it in integral terms, which is a good way to do it, we could state that the water temperature average is equal to the integral from 0 to 15, 1 over 15 minus 0, or just 1 over 15, and we're going to use this function, and that'll give us our average water temperature. So remember, we have to use a trapezoid to solve this, and then we're just going to multiply that by 1/15. So to use the trapezoid, remember, I'll just draw a little quick picture here to remind you. If we were to do a trapezoid, on this interval right here, and we split it up into these little sections here, and let's say they're all equal 3 as well. Well, the first trapezoid, I'll try to shade it. First trapezoid is in here, right? And the second one is this section, and then we have one here, and let's see, I guess I can use blue for that. And let me label these heights right here, A, B, C, D, and E. So we have 1, 2, 3, 4 trapezoids. Well, this is the height. The height of A, we're going to only use that one time, right? Because it's just this leg right here. It's just that first yellow trapezoid. And its other base leg is going to be the height of B. So that gets used once there. But whenever we look at the area of the green portion, it's made up of the base from B and the base from C. So B is used twice, A is used once, C is used twice, D is used twice, and E is only used once. So just a little refresher that we can do this a little bit quicker since we're going to use the calculator if we consider that. And then since we have equal delta t's of 3 days, we can just multiply that out at the end. So let's just set it up. I don't want this video to get too lengthy here, but it's good review, I suppose. So just the area under the curve using trapezoids is the formula is what? Now let's write it up here. Area for a trapezoid is 1/2 base 1 plus base 2 times our height. So our 1/2 and our heights are going to equal to 3, right? And then we're going to just sum up the function values at function value w of 0 plus 2 times w3 plus 2 times the value at w6 plus 2 times 9, etc. until we get to 15, which we're just going to use that one time. I guess I should just write the other one too since I've already committed to it. Okay, and that's going to be that. All that stuff added together, multiplied by 3/2. So if we add all that up, let's see if we can get that here. 20 plus 62 plus 56 plus 48 plus 44 plus 21 times 3/2. When I did that, I got an area. The area underneath that curve is 376.5. So this area is basically your W water temperature accumulation, right? So they want the average. And let's think about this for a minute. We just found the area of degrees times days, right? Degrees times days. And whenever we use the average value function up here, this formula, we're going to divide out the denominator, which is 1/15 days. So the days is going to cancel out, and our answer is going to be in degrees. So I'm just going to take my my answer, 376.5, and multiply it by 1/15, and that's going to give me looks like negative 0.549. No, excuse me, 25.1 degrees Celsius. I was looking at the next part. So the answer to this one is the average temperature in the pond is equal to 25.1 degrees Celsius. Alright, I think I should have pulled the calculator up on the screen, but I think everyone's pretty good with this part. So let's take a look at part C. It's kind of a long problem. So part C is asking us, they're giving us an equation, and they're telling us that this is a model for the temperature of the water in the pond at the time t, where t is measured in days and p of t is measured in degrees Celsius, and they want us to find the derivative of 12 using approximate units. Explain the meaning of your answers in terms of the water temperature. Well, since this is a calculator portion, we can just put this into our calculator, if I can find it here. Okay, so let's put the equation in right here, and it's 20 plus 10x times e to the negative x divided by 3, and we can just take this derivative from the home screen now, and we're trying to figure out the derivative at 12 and maybe compare it to our first one, I don't know. So alpha f2, whoops, let's try that again. Yep, alpha f2, and we're going to take the derivative number 3 and use an x, and we have that in the equation y1, which is, the shortcut is alpha f4, and x equals 12. So we get a negative 0.549 negative. So using appropriate units, explain the meaning of your answers in terms of the water temperature. So let's go ahead and write down what we have. We have P prime at 12 is equal to negative 0.549 degrees Celsius per day, and the meaning of that is it just tells us approximates the temperature drop per day at 12 days. So I think that's probably about all you need to say about that part. Part D says use the function defined in part C to find the average value in degrees Celsius of P of T over the time from 0 to 15. So this is very similar to part B, where we approximated, but here we're actually going to use this function to find the integral. But luckily we still have that in our calculator, and so we can just punch that up. So it would be 1 over 15 times the integral this time from 0 to 15 days, and we still have that in our function at 1, and it's in terms of x. Just let the calculator do its thing, and it tells us that the average temperature over that 15-day period was 25.757 days. So if you wanted to get your full credit for this, they did define this function as P of T, so we don't need to rewrite it. if they give it to you in the problem in terms of a letter, you can just simply write it like this. So part D, we could say the average water temperature in the pond is equal to 1/15, 0 to 15 of P of T dt, and just spit out the answer, and it would be 25.757 degrees Celsius. So hopefully this helps you. Some of these problems can be intimidating with the tables and using trapezoids and Riemann sums and those kind of things. But once you get a little practice with these, there's not a whole lot of things they can throw at you that are different than this. One thing you want to remember is just pay particular attention to the units and keeping in mind what the derivative is. It's just the slope. So in our case here, it was water temperature, the change in water temperature divided by the change of days. So that's just Celsius divided by days. So just keep your units straight just by knowing that you're doing the slope if you're doing a derivative, and the area under the curve if you're doing an integral. And when you're doing the area, it's equal to length times width, and that would be, in this case, degrees Celsius times days, which isn't a very helpful unit. That's just the accumulation of temperature over a certain number of days. But whenever we take the average value, remember we're dividing it by that. In this case, it was 1/15 days, and the days cancel out, and that's why the average temperature is just degrees Celsius. So keeping that in mind as you're doing these problems, it'll make it a lot easier. So a lot of times you can find out what to do just by reading the question and finding out what they're asking you for. The average value in degrees. If you take the integral and not multiply it by that 1/15, and your units will mismatch. So anyway, practice, and good luck.